I'm going to show you how we navigate simplifying these type of expressions. Again, we call them rational expressions because they are fractions. They are fractions. And I'm only going to do this once. I'm only going to do it once. I'm not going to do it every time. It just take way too much time. But too often we get used to just doing things in mathematics. We don't know why it works, okay? What are both 54 and 24 divisible by?
6.
They're both divisible by 6. And so what I'm going to do is I'm going to factor a 6 from 54x squared. And I'm also going to factor a x. And so I have 6x times 9x. Does everybody agree that 54x is the same as 6x times 9x? Okay. And on the bottom, you agree that 24x is also divisible by 6x. So I'll write it as 6x times 4. And so what we're actually doing in this situation is we're taking this one fraction, we're making it into two fractions, 6x over 6x times 9x over 4. And so when we talk about canceling or crossing stuff off, it's really bad verbiage mathematically to say that we cancel or cross off, because it kind of makes it sound like it disappears. Rather, let's understand that 6 over 6x doesn't cross off or disappear. It reduces to 1. And anything times 1 is itself. So it doesn't necessarily cancel. It reduces to 1 and gives us then 9x over 4. Okay? So that is the functionality of what's happening. The key is to write it in factored form. Factoring means to write it as multiplication. Notice how I wrote it as multiplication. So some people will get to a problem like this and they'll start doing this. Hey, I see that the x's cancel. And then I've got 5 over 10, that's going to be a half. And then 20 over 40, that's a half. I've got an x squared. We go 1 over 4x squared, okay? And you do that, and that just, I suppose it would make sense to some people. You know what I mean? You took a third grader and said, hey, here's how you do this. And be like, okay, we know that that's not right, is it? That's voodoo math. You just made up a bunch of stuff there that doesn't actually work. And the key is this. You have addition and subtraction. You can't be canceling stuff off with addition and subtraction. You must write in factored form. What can you factor out of the top? So you take out the 5, you're left with x minus 4. And what can you factor out of the bottom? Take out the 10x, and you're left with x minus 4. Now they are written as multiplication. Because they are written as multiplication, we can then reduce the x minus 4 and x minus 4 to 1. So 5 over 10x reduces then to just 1 over 2x. We're done. You should also be able to multiply rational expressions. Multiplying rational expressions, not any more difficult than simplifying them. All we have to do is we have to look and see where things will reduce. In fact, because multiplication is commutative, you can move things back and forth. So I don't see a reduction here or here, but if I were to rewrite it as 4x over 2x times 3 over 9, I definitely see reduction there. Don't use the word cross multiply. We don't cross multiply. You maybe cancel across from each other. You cross multiply if you see an equal sign in between, okay? So say you saw something like that. That's where you cross multiply. You see an equal sign in between. This is not cross multiplication. 4x over 2x reduces to 2 over 1. 3 over 9 reduces to 1 over 3. We get 2/3. Piece of cake upside down. The next expression, again, the temptation is to just say, hey, I'm going to get rid of the x squareds and the x's and stuff like that. You're making stuff up. You must first write it in factored form. How does the top trinomial factor?
X minus 1, x plus 2.
Good. X minus 1, x plus 3. And then we have an x minus 2. I'll just join that together as we multiply. And the bottom obviously factors to an x minus 2. And now that it's all written in factored form, we're allowed to reduce to 1. Notice the x minus 2's and the x plus 3's. And we get x minus 1 over x plus 1. But isn't it so tempting to just say, well, I'm going to get rid of the x's and say it's negative 1. You know what I mean? We don't do that, okay? Can't do that. If you're ever wondering if you can do that or not, sometimes I just pick a number and plug it in for x. Suppose x was 7. Then you have 7 minus 1 over 7 plus 1, which is 6 over 8. Is 6 over the same 8 same as negative 1? No, it's not. So that tells you that you can't do that reduction. So does not work. How do I divide? Multiply by the reciprocal. So there we have it. We have 2x over 3, and we're going to multiply by 12 over 6x squared. And you can look across and work to cancel. Okay, 12 over 3 becomes 4 over 1. And 2x over 6x squared becomes 1 over 3x. Now as you multiply, we have 4 over 3x. In my next expression here, again, we see the division sign. So I'm going to raise x squared minus 1 over x plus 3 and multiplied by x squared minus 9 over x plus 1. So I flipped it using the property of that multiplication. I go ahead and factor. And on the bottom, x plus 3, x plus 1. And we notice in the situation that x plus 1 reduces, x plus 3 reduces. And so you're left with x minus 1, x minus 3. And there's my factoring. Good? You guys are usually really good with this stuff. Okay? We usually don't get these problems wrong on the test. Adding or subtracting. In order to add rational expressions, you must have common denominators. So, very common for people to make this mistake. They say, well, I see a minus 1, so I'm going to do a minus 1. Okay? You can't do that. Just like if you had 3/4 plus 5 thirds, you can't say, well, you know what, we're going to change up 5 thirds to make it a 4, we're just going to add 1 to both sides. You can't do that. Notice that the common denominator is going to be 12. It's 3 times 4, which is 12. So in this situation here, the common denominator is going to be x times x minus 1. That's our common denominator. So in this situation, I'm going to multiply the top and bottom by x. And in this portion over here, I'll multiply the top and bottom by an x minus 1. And so I get a 2x squared. I get a plus 3x. I get a minus 3. And in the denominator, it is x times x minus 1. It's very customary to write the denominator in factored form. If you multiply 3 on the left as x squared minus x, that's fine. But often leaving the denominator in factored form is of advantage to us. It is possible that the top would factor and cancel something there. That does not happen in this situation at all. Talk to the person next to you about letter B. What would you do to come up with a common denominator there? Go, Tom. Okay. Notice that if we have 5/8 minus 7/4, the common denominator we do not leave as 32, agreed? If you had the common denominator as 32, the problem would work. However, in the end, you would need to simplify your result, meaning there would be things to factor out. So in this situation, if you did multiply the top and bottom by x plus 2 and the top and bottom by x squared minus 4, that would work, but there would be factoring that would have to be done at the end in order to reduce it. Yes?
Could you just multiply that one side by x minus 2?
Exactly. So just like in this scenario, you would multiply top and bottom by 2 and do nothing here. That's exactly what we will do here. Notice that this factors to x minus 2 times x plus 2. So therefore, you only need to multiply top and bottom by an x minus 2. Now, that would seem like the most common mistake that people make, but it is not. In this scenario, the most common mistake is that people do not handle the negative correctly. So let's just make sure we keep an eye on that. You have 5, and I'm not going to distribute 6. I'm going to distribute a negative 6. Negative 6 times x is a negative 6x, and negative 6 times negative 2 is a positive 12. And my new denominator was x minus 2 times x plus 2. You can combine terms together. 5 and 12 make 17. 17 minus 6x over x minus 2 times x plus 2. And that is my result. Again, all these pieces you've seen before, we're trying to prime your brain to be able to have good pace as we move forward the rest of this course. When you see your video on Monday, it will be solving equations. We're going to tell you what to do if you have some fractions involved. We're going to tell you how to solve by factoring. We will also tell you how to make use of the completing the square and even the quadratic formula. Okay? So on Monday, please again bring your headphones, be ready to watch the video and go from there. If you turn to your homework, you are ready to work through problem set. You can finish off problem set 10. And it'll be on Monday that we get to 11. So I'm here to answer questions for the next about 10 minutes. Anybody has them? Oh, yeah.